Hey, welcome back to the channel, guys. Another day, another challenge to keep the consistency alive. Let's see what's on the plate today. So till here we have done. I think the last question that we did was next cricket letter, I guess. Okay. Let's see. LeetCode. What's next? Okay, this one. I think I wanted to do this question. I think from a while back, and I think there is a day. Let's see. Before even opening the question, if I'm thinking correctly, this might be that question. Otherwise, it might be some other question. Okay. In my mind, was the question is, let's suppose you have n number of stairs in front of you. In how many ways you can go to the top of the stairs? Like this is some of the question is there in my mind, and let's see what's there. Okay. You are given with an integer array cost, where cost I is the cost of ith step on the stairs. Once you pay the cost, you can either climb on one or two steps. You can either start from 0 or you can start from 1, return the minimum cost to reach the top of these floors. So it essentially is the same question, just it has some cost implied to it. Let me reread it, and this is majorly to do because I don't get the much of the question details in my very first read through, and let me read it again. So you are given an integer cost, okay, where is the cost of ith step. Okay, it means the first step cost would be this, second would be this, third would be this. Okay, once you have the cost, you can either climb 1 or 2 steps. Okay, and you can either start from 0 or 1, and you need to find the minimum cost to reach the top of the floor. Okay. Interesting question. And so let's visualize this one. I think this can sum of it. I'm just visualizing for my so that I remember it in a longer period of time, not for whether it will bring something new. Let's see. And let's have a stairs. I'm just representing a stairs, something like this, but it does not means it is. These are the same. Okay, the cost are 10, 15, 20. Okay, let's have this. Cost is this. Sorry, like I don't know, like there's some sort of like I think viral going on in my area, or like typically in the area I live in, and I think it's the entirety of the state. I think it's infected by the same traits what I'm suffering also. I think it has been around a week or so, but this cough is not going, but it's definitely improving. Let's see how many days it will take. Otherwise, if it continues, I will definitely check with some doctor, or probably or will eventually learn how to crop this portion from the in my editing particularly. Okay, let's see. So again, these are the steps cost 1, then this would be 100, 1, this would be 100, this would be 1, this would be 1, then I need one more one, and then it goes on. I don't want to do it again. 1 1 1 1 100 1 1 1 100 1 1 1, which means this pattern. 100 1 1 1 100 1 1, sorry, not triple. This last one is 100 and the last one is 1. Let's see. Let's just see. Okay, overall I can start from here, I can jump here or here. Okay, I remember, like, at one point of time I had a look at the solution of this question, and as of now I don't remember it. Probably because I learned, like, I had learned that question, or like mugged up that approach, not tried to understand, like, or not try to develop my understanding of how to do similar questions. Okay, let's try. Let me try. Probably I will give myself 5 minutes of time. I will try to keep the video slightly small. I think that would be a good point. Okay, anyways. 101. In a way, if I start from this number, I have so many ways to go. If I start from, let's say, this number, I can, if I start from here, I can go here or here. If I start from here, I can go from, okay, this is the 0 itself. Wait, a question. The question says start with the index 1. Okay. So essentially I can start from here as well. You can either start from the step 0 or the step 1, taking the minimum cost to reach the top of the flow. I can skip the how can we move this question to not sure. Bit tough. So the approach is, the very first of, do I need to know all the combination, or is there any algorithm or any approach which can give answer to this? Not sure. If I start from this, I can have the approach. I vividly very remember, like, what was it says, like, I needed to be greedy in the approach, and whichever is the minimum, I need to go with that. I think that was the approach. Let's say I start with, I have the option, either choose 1 or 100. I can make this choice that I want to go with the 1. Okay. And then again I have the choice next to, I can make the choice that I want to go with the 1. Again I have the choice, this or this. I can make the choice here. Again I have the choice here. Again I have the choice here and here. Yeah, I think by following this approach, greedy local approach, and I can see a solution. Let's see. Once you pay the cost, you can climb either 1 or 2 steps. Yeah, I think that's the approach which I can think. Okay, so at any point of time, how many loops would be there then? loop would be okay. It's not would be a for loop because I want to go till the length. Okay, it is going to be a while loop. So I'm going to start. Let's say I want to get the length of the cost, cost, and so that's how many elements are there. And then let's say I can start with I, which is 0. Now while I is less than L, I can continue this, and at the end, depending on which condition passes, I want to I equal to I plus 1, else I equal to I plus 2. This I want to do, and then now I need to give the condition. Okay, but for every okay, if I equal to 0, then I need to check. Okay, minimum of I need to get the index of the minimum. Okay, that's not an issue. Okay, if I and I plus 1, let me take first cost of I and cost of I plus 1. If cost of I plus 1 is greater than the ith one, then go with I plus 1. No, sorry, wherever I am, if I 0, that does not mean I'm out of the box. I still am here only, no? I need to choose, should I go to here or should I go to here? Then if I'm on this, I need to choose. And then I need to choose, should I go here or wait a second. Anyways, I'm here, no? Wait a second. Once you pay the cost, you can climb either 1 or 2 steps. 1 I had to give anyways, okay? But I need to find the minimum of this, no? Which cost I want to pay? Do I want to pay this one or this one? I want to pay this one. Then I can go to I plus 2. Then hey, I'm here. Which I want to pay? I can pay this one or this one. Oh, wait a second. I jump in this. I already paid that. Okay, now I can make the choice. I plus 1 or I plus 2. There is some like 2 steps also, I think, for all the okay, so there are three. One approach is to handle the boundary condition over here at the very end. Another is to handle this very first ask, like choose any one of them. Okay, and then the third is to continue with I plus 1. I think I was let's try to do this portion first, and then we'll reach at the end. Okay, I think boundary condition is anyway automatically solved because we are using while loop, no? And that's how it will work. Okay, so okay, let's start from here. I plus 1 and I plus 2. Okay, I plus 1 and I plus 2. If I plus 2 is greater, then go ahead and increment by I plus 1. Otherwise, if it is less, then increment by the I plus 2. That's fine, and we go there, and in the cost, add the value of that. Cost is equal to cost plus no sum equal to this. So sum will become sum, not s plus equal to cost, and then that is specific I value which is there, and now it is incremented. I need to choose which is the minimum. Start with either I or 1, so I can have a loop if cost of I is less than cost of I plus 1, then I is equal to start with 0, okay, else I equal to 1. And then anyhow the sum would be s plus equal to cost at I, and that's how it will start. It will go, and at the end I should have the sum. Return s. That's it. That's out of range. How? Cost I plus 1 and cost I plus 2. If I reaches something which is less than, okay, if I becomes this value plus 2, it does not mean anything, right? If I becomes this, then this does not mean anything. Now I need to make sure a boundary condition. If I is less than yeah man, like how can I close that? Because the while loop will enter for this also. Okay. Or and I plus 1 should be less than L, and I plus 2 should be less than L. Will this work? Let's look at the solution now. 1100. This is correct, and this will fail. Why? Let's see. According to my logic, I will first decide should I want to go on the 10 or 15, and the question will choose that it want to go with the 10, and then I can jump to either 15. According to the while logic, I can jump on either to 15 or 20. I'll see I plus 1 which is 15, I plus 2 which is this, it is less than I equal to I plus 1 which become 15. Okay, so my approach is working, so that's why like it is saying like 10 plus 15, but this is an incorrect approach. Again, the reason being I could have started from 15 and then all, and that's all. So local optimization is also not the solution then, no? Yeah, okay. So local optimization, locally greedy approach is not working. Then how can I make sure that if without knowing what's going to come next, okay, was there any possibility that I could have known that the length is about to get over? If the length was getting over, then I could have kept the 10, 15, 20. 10, 15 and 20. not sure. I could have easily gone for like n number of length, and it could have passed also. But in this question the problem is immediately I know that I could have exited also. I can put that into some sort of logical flow and I think this will pass, but the problem is, so what I put. The most optimal approach I think which I would like to see is like if I take from left to right once and then I know what's the answer. Can it be a possibility? If I can make a dictionary 0, 1 and 2 and then for 0, not sure, what should I do? I'm not getting 10, 15 and 20. 10, 15 and 20. How do I know if the element of the list is going to end? If I'm only at this, okay, I can know if by the length. Okay, so in order to decide the first, if I would have checked if the length is less, then I could easily jump in this. But this holds valid for every other condition also, no? But I think let's say if in this condition I'm making local optimal thing. Wait a second. I have a gut feeling that okay, let me show you what I meant. Okay, in order to decide the very first, okay, I could have checked either the minimum of this, which if this is minimum, which will come out to be this. I could have checked the length of the, I know the length. What is length? Half. If length half, which will half plus 1 I will have to do, I guess. Half plus 1 is 0 or 1. Cost in 0 or 1, 0, let's say I am on this. Now I can check if or I know, but okay, this condition I should not have checked in the starting. I could have just checked here the minimum of cost L divided by 2 plus 1 or S. I think this will, if cost L divided by 2 is logic is correct. L divided by 2 logic is like, I think it takes 20. Okay, how 20 is output? Okay, plus 1. No, it's correct. Okay. Okay, this is what I meant. getting answer is okay, but this is no way, like I'm not confident at all that this would be a good solution for anything, right? And yeah, see here also. Here what I check, cost L by 2, which means like the half of the list. Half of the list is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5. This is the list. Okay. So in a way I'm checking if this is which is like wrong, no, like which is 100% wrong for sure, but still giving the correct answer. Okay, so I think I will take a pause to settle this question, like or probably I will discuss with my friends. So whenever I discuss with my friends, I don't tell that I am looking in terms, like in context of DSA. I ask like a general question, how they see the problem. Okay. Oh, if I get the chance to talk with any one of my friends, like in normal life, otherwise like I will not ask. I will just let my brain think about it. But still, it's an interesting question. In a way, it says like, let's say this is your and you are here and your life goal is here, and this is the, let's say, the time it takes. Okay, so at what thing you like at what skill set, and these are individual skill set which you need to learn, and these are the amount of time. Okay, so at which skill set you need to spend time so that you can reach your goal the fastest. Yeah, that's the, in a way that's how it is. But let me give myself one last minute, otherwise I will go ahead and pause the video and probably come back later on to think how I could have to do. Just give me 1 second, like I will take a pause and I'll just rethink. Say I am at 1, then I could have gone to think in the direction which question is asking me to think, but let's think individually. If I'm at 1, let's say I'm here, ignore this, let's say I'm starting with this, I could jump here or here. Okay, if I jump, I somewhat remember I vividly remember some arrows, something it was that if I jump from here to here, it is already included, something with Fibonacci, not remembering exactly. It was saying if I jump from here to here, say let me make another one, and then here to here, something was already getting included. If I'm at 1 and I jump at taking the minimum, thinking the minimum, let's not put this question, let's see this question, which was 10, 15, 20, 10, 15, 20. Let's look at this. 10. In this question, I was lucky. Wait a second. Isn't it a special case of no, but 15 is anyhow not less, it's not same. I could have chosen 13, but then 10, and the next could have been 15, and then that's the wrong answer. Somehow if I know the length, if I know if I know the length of it, and I see it is coinciding with and it is becoming 1. Okay, wait a second. If I see this part, if L divided by 2 equal to 1, it becomes 1, then I can check. That will not be the case. Then I can check, and then I can return this, otherwise return S. This will also give me the correct answer, no? Yeah. But will it give in all the scenarios? Okay, let it settle. I am not able to do it right now, but probably I will retry it. Again, don't worry. I mention this in every video. Don't worry, I will not look at the solution. My priority is also to walk you guys through the actual learning cycle, not the tutorial. It's not a tutorial of any kind. It's a way to emphasize you guys also to take the learning slowly. I am not in a hurry to solve this problem. That's not my intention. Okay, anyway, thank you. Bye. Hey, this would be another day if you're hearing this, and I gave some thoughts around this question, but I'm not as of now I'm not able to see for a potential solution, and the solution which is coming in my mind is not guaranteed to give the solution just because of this combination. In my mind, the combination was, let's say, okay, I was doing something. So let's say I am here and I want to go here. I have the choice that I can choose between this and this. Okay. Because at any point of time, this is also given in the question that either I can start from 0 or either I can start from 1. So the very first choice which I make is 10, and then I can go to 20, but this becomes 30, and which is not the what is required. This is the only approach which is coming to my mind, but I think it's not guaranteed. But I still vividly remember that there was something combination was there in which if I reach here, all the minimum has already been calculated till that point of time. I get it, means let's say if I'm here, okay, so every minimum till this point of time would have been calculated. It was something like that. I'm not remembering, but I would like to go ahead and see the solution of it, and let's see how it goes. I was not able to find the solution of it. Okay, so the question name was minimum cost climbing stairs. Was the solution of min cost climbing stairs? how it can be done. Key idea is it's a DPP problem. Let's DP equal to minimum cost at to reach the step I. We want to reach n, one past the index transition. DP0 is start with 0 cost. If you are before stepping to 0, alternatively set the base differently. DP1 is equal to start. I don't know what does it mean, because to stand out of the position I, meaning you have reached index I, which may be n, you must, I don't know, sometimes I don't even get the English translation, and maybe like there are so many things in my mind, probably that's causes this. But I think if you're a college student, this would be slightly easier for you, because like as a college student, I think it's easier to find patterns. Like this is what I feel. There's no such thing like as if the brain has limited capability. Like if you're a working professional or a college folk, or like some student or anyone, I think the level of attention that we give different things in our life becomes a key point in our new learnings as well. Okay, so that's the point. Okay, anyways, let me read through it again. What is this approach? Let's say problem that I tell it to a layman person, how can he get the solution? Okay, it will take time to think. That's it. Okay. Meanwhile, it is coming. Like, key idea is dynamic programming. Let BP is the minimum cost to reach the step I. Okay. We want to reach n, one past the last index. And just a second, I'm hearing some noise. Are you also hearing some noise or what? Wait. Sorry, I don't know. My iPhone Apple Music automatically started. That's why I was hearing some noise. Okay, anyways, sorry about that. Not sorry, but apologetic for that. That should not be the case. Anyways, I hope like by now, if you are the audience of this channel, like, you already know how I learn and things. Okay. Anyways. Okay, so what I was looking at. Okay, so till here the statement is saying like, let's say there is a DPL list, and where the index represent the cost to reach that particular index, minimum cost to reach. We want to reach the n, like the just before the last index transition. DP0 start with a 0, and then DP1 you can start at 1 for free. For I greater than 2, what? Okay, so there is a list. Okay, so the question is somewhat telling me to do this. Right, let me keep it slide. I'm just writing it here. So it is saying that let's say I have a list, and I can start with 0 0 0 0 0, however was the length of the and then it is saying I can start with making this as 0 and make this as 1, because like in order to reach very first index it takes 0 effort. But wait a second, dp of 1 should also be 0, yeah. Okay, now for any I which is greater than, like for this part, like let's say if the list is longer, for example in the second case of our with 1 2 3 4 something like this, so this will increase. So for this portion till the very end, I think what we need to do is something I need to read, because to stand out at the position I, meaning you have reached the I which may be n, you must have came from I minus 1 or I minus 2. That is correct. Let's say if I am standing over this, I would have come from here or either from here. Correct. Now alternatively, many people implement, people can implement this solution. Okay, that's really impressive if someone can think of this in the very first go. BB cost I plus the minimum of the current cost plus the minimum of whatever can be reached from the previous. Isn't it like what we also did, but the cost was not there? This is cost I, okay, and then the minimum of this. This is what the minimum, no? I don't know what's problem. Okay, so answer is equal to minimum of dp n minus 1 and n minus 2. Okay, I don't know what this is. Optimal iterative order of one space. Okay, let me ask one then. Okay, let me remove this with my approach. So, let it think. Step 0 is 10 is the cheapest, 20 is the cheapest. Step 2 is 20, of course. I need to give, and this is but this is not the correct answer, no. Now to reach the top you can finish from 1 Okay, I can have this number. But man, sometimes things are difficult to understand. Otherwise, testing me whole day. It's like shopping your way up the stairs. At each step, ask, what's the cheapest bill I can have in my pocket if I land here? Yeah, that's correct. But man, I don't know what's happening. I can close it out and open it again. Using whichever of the first two is the cheapest step, start there. Might start on the more expensive step that leads to the skipping the bigger later. Yeah, that's correct. However, you're looking for the immediate next step, picking the cheaper one. This is the greedy approach. Only looks ahead by one move, but they requires all the possibility to reach the. That's why tiny bomb was and greedy fails. The ending condition does not ignore the problem. But in your scenario also, what is that? Let's see if it gives the answer. Great catch. Let's carefully untangle because this one it's all about what step 2 means and where the top actually is. Problem reminder, we want to, I know this, and the DP calculation says that, let's say in the top 3 is the index, minimum cost to is 10, minimum is 10, and DP at 1 is 15. DP at 2 is the cost of 2 plus the minimum of, which is this. Okay, now reaching the top, index 3. To reach the top, we can either come from step 1 or either come from step 2. Answer is equal to minimum of 15 why it makes sense in plain words. If you start from 1, that's why 15. But where is the logic of this part to reach the top? We need to stand on the last step. We need to learn how can you reach the top. The rule says from the stage you can move to the IL, which will cost n minus 1. Let's say the n is 4, then the, okay, wait, let me look at this. If the answer is 3, then 3 or 2. Oh man, what's this? The logic is not an arbitrary formula. So we are first preparing the DP list. Exactly the same approach as what I did, choosing the minimum plus cost, and then let's say the length of given input was 100, then we will do just minimum of dp of 100 or dp of 99 is correct. Yes, you got it almost perfectly, just a tiny bit index and correction. You are right that we will the DP list where the DP of I is equal to the minimum cost to standard I, and then this is exactly what we described. Then take the minimum of two possible ways to get there, then blah blah blah. What's the top term is equal to less than blah blah. Okay, yeah, that's correct. That's correct. Okay. So I think okay. So we also prepared something. What was in our case? Was it a list? Okay. So it's not a list. Okay. So I think okay. Hopefully you are also getting. And so in a way, let me start. So first I prepare a list. Okay, but wait a second. Okay, anyways, I will think. Okay, so we have a list. I make it a DP, and it should be, I mean, like, no. Okay, it's true. So first element would be cost 0, and then cost of 1. No, it should also be the cost of, this should also be 0, no? But they have also cost associated with them, no? I don't know. Okay, wait. Minimum of cost 0 or minimum of the cost 1. Okay, this will this will give me the initial values for these two, k comma k, and now let's add how many left? L minus L is the length minus 2. I start with a 0 and then multiply with the length minus 2. Okay, this is, let's say, 3 minus 2 would be 1, and then this 1. Okay, so I have the list prepared. Now I need to iterate from 1 to last. Okay, for I in range start from 0, 1, 2. For I in range 2 till the length, and then for each I need to find cost at I, and then plus to the minimum of cost at I minus 1 or cost at 1 I minus 2. That becomes, it will go at the dp of 0, not sorry, I, and yeah, this will become the dp, and the result would be the minimum of dp of L minus 1. L is like 100 minus 2, no? Minus 1 would be what? Let's say if I have 100 element, the indexing will be 99, and okay, so it will be minus dp L minus 3. Okay, let's try. Something is fishy, no? Okay, let's look at the solution quickly. I don't want to default it to this one. Where was the solution? This. Let's ask right away. Why it is L minus 1 and L minus 2? I don't know what's happening. L is equal to length of the cast, dp essentially the same. Let's do it. Let's take it from this one. Let's see. Not sure what was the problem. Was probably this part. dp of 0 into L, and then okay, if that's correct, what was the mistake in ours? So let me do it to 0 into L, and then dp of 0 is equal to cost of 0, dp of 1 is equal to cost of 1. Let's see now. What's this? Not required. Why it's taking so much time? L is 0 times L, dp of this cos for I and raised 2 to the L, dp cos I minimum dp. Oh, what the hell? This will be dp now. Go to the previous and find what's the value of that, not in the cost. Yeah, sorry, I was mistaken. use the previously built solution. Yeah, that's essentially what we are doing. Okay, so now that we have a solution, let's take 1 or 2 minutes to understand what a layman will do. So in theory, we are going at every step. Okay, here the minimum is 0. Okay, here the step is 10. Here the minimum to reach this would be, hey, wait a second, why it is 1 here, the minimum cost, isn't it wrong? Why did I say so? But why of 1 shouldn't it be yeah, sorry for that. Yeah. Okay, is the minimum total cost. Okay, to stand at I. Correct. So in order to stand at I need to give the 15. Okay. Then in order to stand at this one would be, what's the minimum of these? 10 would be 30. Okay. 30. Now the minimum of these two is the answer. Okay, cool. I think this was a learning, and it was a good topic. Probably we were overlooking something, but anyways, it's not a time waste. Thank you so much for your time. I know the pace of the videos. I'm still learning to make it more interactive, but at the same time I have some excuses that I can make, but I don't want to bore you with excuses. Anyhow, thank you. Probably in the future I will talk about it, but yeah, thank you. Bye.